Hello, guys. Welcome to our stream. I am Shefas, and we
Hello, I'm
have
all. Just like
yeah.
I mean, yeah, that's just like hello, I'm Ohage, Signum Dev, and nice to see you here. So go on, Sheffield. I'm sorry to interrupt you.
uh,
Start away.
Today we speak about Signum Security, and Oliver will show his case stuff. Sorry, guys. And let's start from showing some our community members' creations on Signum Art. It is BCX. He have many collections. I think I give it away some Godzillas sometimes ago, and we have maybe a few months ago Mystery Hyptogen giveaway. He created some kind of
And there's a new one, the Chronicles of Creation. These are animated ones. That's pretty cool.
yeah,
Just like
yeah. This is
some shout out here.
uh,
I like
uh,
those images.
they are AI created, artificial intellect created, and he just edited them. And today we will giving away this NFT. To get it, you just need to write your Signum address to YouTube stream live chat. Today we stream to the Twitter, I guess, if it works. Okay, every time you can write your questions to the chat, and after Oliver's presentation, we will answer them, or maybe even in presentation time, if it will be related to the presentation. Uh, okay, remember to write your Signum address. I will remember it. Okay, Oliver, let's start.
Yeah, let's start. So this will be kind of a interesting ride for some people. I mean, just like we're not very familiar with cryptography, I'm trying to make it as comprehensive as possible. But this is something I think I see the necessity to point that out and all this stuff behind that. So what we're talking about today is mainly about the accounts structure and the security regarding to the wallets of Signum. And so it's mainly called like 64-bit versus 256-bit. So there are kind of basic things I'm trying to cover. I'm not a crypto expert, to be honest. I just applied the cryptography we have here, and so they're kind of not exact things because it's an exact science. To be honest, please forgive me. It's just a disclaimer of that. So. We're starting with a very basic thing, is like crypto algorithm. That means that Signum, like other crypto coins and all this stuff platforms, they use a kind of an algorithm or a set of algorithms behind that to create the security to guarantee that. For example, Bitcoin is using something that's called SEC256PK1. This is like cryptographic name already, and it seems really only the analysts and experts know exactly what they're doing. We're using something that's based on called elliptic curve. I don't want to get into the details of that, and that's a specific curve. It's called a 25519. We're using a certain algorithm for signing and all this stuff. So I could go into the curve stuff and seeing, but actually, as I said, I'm not the mathematician, a math guy, let's say like that. And it doesn't matter really. The only thing is like that BTC and Ethereum using another kind of elliptic curves. It's not worse or not better, whatever. So they're comparable in terms of security, but they're not compatible with Signum. So that means, for example, I cannot easily just like take my Ethereum account and put this into Signum. It doesn't work because the key generation stuff is completely different. The outcome is different. It seems similar, but it's different. So they're not compatible, but in terms of security, they're the same level. So the next step is like, what accounts in Signum? Because it's sometimes a little bit confusing. Even when I started in Signum, it was confusing to me. It was like, Okay, wait, we have IDs, we have read Solomon addresses. What the fuck is that? Nowadays, we have even extended address. I'm showing that here in public keys. So these are different representations of an account. And they are kind of, I will show you how they are generated and how they are like entangled and how they stay together, how they're intertwined. First of all, the ID is just a numeric number. We mainly in the front end stuff, like in the Explorer, in the wallets, and we see them sometimes, these numbers, and these are mostly positive long numbers. Then there is this address. This address starts mainly with the S. So the S in the beginning here, this is one just the called prefix. Actually, this prefix has nothing to do with the ID on that. This address is just a specific representation, which claims to be a little bit more human readable in that format here. And then we have the extended address. I will just talk about this in a few seconds. There is something more with these addresses because this read Solomon algorithm behind that is able to correct if I digit or entered this like wrongly. But I confess, for example, I created the Phoenix wallet and even the XT wallet. I don't have any autocorrection mechanism implemented for that. For me, it's just like a string I use. And then there's the extended address, which is apparently seems or looks similar, like, for example, the Reed Solomon address with something weird here behind. This weird here behind is nothing more than another encoding of the public key. And that is where we are looking more into the extended address. We will just like fade out of this presentation because it's just like kind of sugar on top of that. But we're talking more about the ID versus the public key today. And the public key here is like represented in an hexadecimal pattern, like
Sorry, guys. I think we have problems with Oliver internet. I hope he will return soon. Let's try to write him. He is out from Discord. So it's a very sad situation. And he is disconnected. So guys, be patient. Let's give him several minutes to return. Sadly, I have no his slides, and I'm not prepared. Did you guys know where is atomic swap for some? Maybe he is asking when atomic swaps can be done if you have same protocol. So you can say that our tokens tradings are atomic swaps. You can say it is not same, but it's like this. So if someone will fork Signum and create own coin, you can do atomic swaps between Signum and this other coin who uses same software. It's between BTC and Signum. Sorry, it is not possible to do. You need to do to have some mediation or something. I mean, you need to have something in the middle. But you can do like we did with BTDEX. So you lock some amount on one chain, you lock on other chain, and have some mediation and release it. And I know you can lock on BTC. too. Okay, he's connecting with mobile data. Ah, okay, okay, let's wait him. Frank writes that I played some music, but I think YouTube is have some copyright problems. So
I'm back.
yeah, I
Back.
answer is
Oh, wow. Sorry, guys. Finished. Okay. What was the last part? Which was still transmitted? Where's
uh, please share your slides. Ah,
So okay, I'm getting these are the things that makes me nervous. Let me see. Share here. Oh, I'm so sorry for that. What happens? So yeah, I think that I talked about is
yeah,
correct.
you talk about this.
I talked about this, and then that was the derivation when I saw, talked about the recovery seed. I think I will start here again. So you got these 12 words, and these words are put in kind of a transformative, and that one is like generating a set of keys. So first of the key that's being generated is the public key. And in Signum, there is not only the signing key being generated, but there's also an agreement key. This has something to do with the peer-to-peer encryption between accounts. This is something not every blockchain has this, and yeah, this is an additional encryption key that is really neat for that stuff. So, and once we have the public key can be transformed into an account ID. I will just show you how this works roughly. And the account ID will be encoded into that Reed Solomon address. That is what we are used to use all over the places because it's a little bit more eye friendly, let's say like that. So if we go and see where's the connection between the public key and the account ID, then it's like that we say the public key is 32 byte string. It's like 256 bits. I will talk about this just in a minute. And the account ID is only the first 8 byte of that. So we chop off the first 8 byte, and then we making there's been some encoding to complement the idioms. That this doesn't matter. It is really the only programming thing. But that number literally will be transformed into an into an integer number, a long number of 64-bit length. So what is this bit stuff about? Let me see. I have this somewhere. Okay, I'm coming later. Okay, just like come to this a little bit later. I just want to show you that there are a kind of combination of ones and zeros, but I will skip that part at this moment because we come back to that one. The only important thing at this moment is that we know, wait, we have an account ID, which is 64-bit length, whatever this means at this moment, and we have a public key, which is a length of 256-bit length. So the space of the account ID is much smaller, the address space, than of the public key. And this has some serious implications. We're talking about this. So before that, I just want to point out something. The account creation, how does it work on Signum and similar to others also? But due to that mixture of account ID and public key stuff, there are kind of characteristics we need to consider there. So first of all, many people think when they download the wallet and they create an account there inside, they think wow, now I have a wallet and now I need to get money in my wallet, my values. So, and many people think that the wallet or the values is stored on the wallet on their device, but that's not the case. It's stored in the blockchain, and we'll talk about this a little bit later. So with this means an account creation has possible states. Once I created an account with, for example, with Phoenix or with XT or with BTDEX or with Neoclassic or with Classic or with other wallets around there, then it's like I have it created and I have the keys on my device. But the blockchain has no register about something on me. So I do not exist in the network yet because I haven't done any transaction. So if you go to the Explorer right after you created your account and you look for your account ID, you won't find anything. It will say account not found. This can be confusing for newcomers because they just like thought that, hey, I'm there and I just created my account. No, it needs a little bit more. It needs to be registered. So there are two states you can get there. You are kind of registered. So there's something like a transaction. You received, for example, something, but there's no public key assigned to your account right now. We talk about this in a few moments, what that means. So it's just like a step. That means that we consider the account as not protected. And the other one is like, it's registered and we have an assigned public key, and this is what we call a fully protected account. There's some side effect. If there's an account which is registered without a public key, that account cannot receive encrypted messages, because the encrypted messaging works only with a public-private key encryption, and that if the recipient has no public key yet, I cannot send, or at least he cannot encrypt the message or decrypt the message then. This is such a side effect. It's confusing a little bit right now, but trying to get back on track a little bit. So what I said is like, we have these three states, and I said we have 2.5 ways of registering accounts. The question is, hey, when I'm not registered, how can I register? The first thing is do an outgoing transaction. The second thing is like we can receive something, a message, coins, token. We're doing something like join a pool, which is the reward recipient setting. We can set our account information, like our profile and all this stuff. And if we receive something from outsider, like saying like, hey, dude, send me one Signa because I just created an account. It's possible that he sent it to your account ID, but he hasn't attached the public key to that. And that means that your account ID is registered in the blockchain, but there is no so-called public key assignment yet. This is a problem. And the other way is like we have this all together and all this stuff. And there's something that I call a hand-egg problem. And you say like, hey, how can I do an outgoing transaction without having Signa? Because transactions, we know that on a blockchain need to be we need to pay fee to the miners, because they do all the work and all the stemming. They do all the stuff for securing the transactions. So how does it work? So I create an account, I do make an outgoing transaction, I need Signa, but how can I get Signa in that way? And it's like, yeah, you're running in circles a little bit. So you can ask someone to send you Signa, or you can use a kind of a sending service, also known as faucets. Other chains have this also. So you're going to a certain service, somebody's running that service, and that service is charged, or behind there is an account that is charged with amount of Signa. And every time you register a new account, so you get this money from that. And in Signum, it was before 2019, it was the way that all was worked with faucets. And there was like a multi-step process you have to do. The user has to go to the faucet. So first he needs to know that there's a faucet he has to go to. Then he goes to the faucet. Then he registers there. And then the faucet is transferring money to him. And then the user has to make an outgoing transaction, like joining a pool, which is like, most people probably start with mining or something like that, or many people start with that, or doing other things then. So the faucet had also a problem that it needs to be protected against farming, because people start to farm, and then there's like IP protection, and there's a lot of protection mechanisms behind it. So it's like, to solve this hand-egg problem somehow, it was like doing this centralized service. Yeah, that's one. So how it is solved nowadays to make it more user-friendly? So since the mid of 2019, so it's more or less with the rise of the Phoenix wallet, there was introduced a so-called activation service. I can show it you quickly. Let me see. So there's one way to make it as an interface, and that interface requires you to enter an account ID and a public key. And then when you do this and activate, then this account or this service behind it works similar like a faucet, but it sends you a small fee like the faucet does, and also it makes a public key assignment. So implicitly, your account gets protected, say like that. So going back to that one, F11. Yes. Okay. And this service is also not only the UI, the front end stuff, but makes no sense because for automation we have as an API. It's a service that can be called programmatically. And the BTDEX, XT wallet, and Phoenix wallet use it. I'm not 100% sure about the Neoclassic wallet, if that uses it right now, but for sure it will. If not, Ethereum will do this. I will do this for sure, because that's just really vital for our stuff. So you get, this is done when you create an account, you get your welcome message together with some fee. I will show it to you, like going to this to understand this a little bit better. So if we go, for example, to the Phoenix wallet, then we can do, for example, go manage accounts. And I can create right now an account. So you see, for example, here's a new account. I can always just hook into this to see what's going on here. Wait, I selected account. Ooh. I'm going to that one, selecting, and can select it that way. So it's being selected. And it says me that's a new account. Okay, you see that's something that's very interesting to see. I can do this directly here. It says clearly, this account is not registered in the blockchain. This account has no transactions yet. If you intend to use this account for sending and or receiving, it's recommended to activate/protect this account now. I would do this right now. So I just like click that. I click that. Yeah, okay, so you successfully requested protection. Your account will be protected in a few moments. So it comes here, you will see in a few seconds, there has to pop up here the transaction. We can follow that, let me just like about 10, yes, you see, it's coming a payment. I'm running on testnet, but it's the same or very similar on the mainnet stuff, but you don't get 10 Signum. So don't try to farm that. Okay, so as you see, there's a pending transaction right now. It's coming from kind of account. So, and this step I don't have to do usually. It's just like, you see, it's considered unsafe yet, this account, because there's no public key. And when I do this, for example, in normal creation of an account, I can generate my recovery phrase here. I'm going here. It's something additionally we added. So in the background, there was right now created a seed or a recovery phrase, and I can add some individual words on top of that. So like a more like distracting factor, a little bit more security for the most paranoid people. Going there, and it says me, okay, that's my account and that's my recovery phrase. Yeah, you can copy that. It doesn't matter. It's like testnet. I need to copy this because there will be some check in a few moments. So I'm going further. I'm entering some PIN to protect my keys on my wallet. And now I need to do something that failed the last time I did this in a call. So seminar, candy, winter, category. So you can all write it down also, and then you can just like get the 10 T signal.
I think you last stream failed to enter
yeah,
correctly.
yeah, exactly. I need just okay, category, number. I need to concentrate myself. Page, picnic, try it, write it down. Don't steal them from me. Loud, rhythm, fever, derive, and the last one is night. So now there's a protect button. I'm doing protection, and you see successfully requested account protection, accounts successfully. It still says that it's not registered because we need to wait the confirmation in the blockchain. So if I hit it again, it just will say, hey, this activation is already pending. So we can wait a little bit for that account. I can go over, for example, to see what happened to the other account I was just seeing here. Yeah, the testnet is a little bit slowly, but once that is settled, then I got my public key assigned. You see that it's an automatic process. The wallets, even the XT wallet, is saying to you, hey, you need to activate or protect your account. So it's all baked into the wallets. That's my recommendation. Create your accounts using the wallets because they're trying to take the measurements necessary to protect as much as possible. So going back a little bit to that one, this is the account creation. That's very important to have this idea. Before I go further, I need to just make let's recap some basics of cryptography and level of protection. So most times we talk about bits. We say like, oh, this is a 128 bit protection, or this is 64 bit and whatever. So let's recap that. So one bit is just a 0 or 1. It's like on, off, true, false, or something like that. It's like what the circuits can do inside. 8-bit are 1 byte. 8-bit means that we have 2 to the power of 8 combinations possible, which are 256 ones of zeros and ones. Okay, we have 8 zeros and ones in a row, and then we can have exactly 256 combinations, including 0, 0, 0, 0, 0, 0. When I increment the bit by one, that means that I'm not having 257 combinations, I double it. So 9-bit means 512 combinations, while 10-bit means 2024 combinations. That's important because in the first moment, many people think like, oh, just like raising the exponent by one. Who's not really familiar with that stuff says like, okay, yeah, yeah, okay, nice, but what does it mean? So it doubles your incrementing the exponent by one, doubles the number of combination. In general, I can say it doubles your security. So that's here. You can see that 2 to the power of 9 is exactly 2 times 2 to the power of 8 is 512. So that's just to recap that a little bit. And as I said, what's the ID against the public key? The public key is 256 or divided by 8, because 8 bit are 1 byte, 32 bytes string. This is a little bit more than 32 bytes. Actually, this is represented in a hexadecimal form, but that means that I have 64 characters because 1 byte is represented by two numbers and letters. The account ID I said already is chopped off. It said like only the first 8 byte are these ones. And these are the implications. So how many combinations are possible with 2 to the power of 64? And how many are possible, oops, I'm sorry, with 2 to the power of 192. Together there are 256. Yeah, that's here. Looking at this, you see there is a lot of that 10 to the power of 19. That's a lot of stuff, and it's even more here. So I will show you a little bit later when we try to make some kind of attack on these account IDs, because you understand what's going on and how this all fits together and where we stand then. So I will show this how much effort is theoretically not necessary or basically necessary, just like to guess certain combinations. So we come to this a little bit later. Oh no, we come right now to this. Lost in my own.
Sorry,
Yeah,
Oliver. I will give quick shout out about BCX NFT. You can win this by entering your Signum account ID to YouTube live chat, and later I will after this meetup I will do this random pickup, and one guy or girl will win this mushroom magic.
yeah.
Okay.
Just taking advantage of that interruption. Are there any questions right now in the chat? Probably there are kind of questions that belongs to that factor and can be answered.
It is not related to your presentation. We have one question about how this vote. You can all read this, and we answer it later. Maybe
Yeah,
we'll show Explorer,
yeah,
and we had answer it, but talking with no hard cap, and
yeah. We
it
can.
was
That's
yes.
yeah, yeah. It's already answered. Yes, that was a very easy, not off-topic question, but yeah, we can do
Mhm.
immutable tokens. Okay, so I'm going on a little bit here and want to explain a little bit how where's the flaw here. So if we have inside our blockchain the account only registered without the public key, then it's possible to try to understand that. It's possible that I can assign any public key which matches only the first 8 byte of my account ID. So I just try to depict it the way here. The original public key from my seed that I have done is that long here. Oops, I'm going back. And now I haven't assigned my public key, and I just sent, for example, I have a wallet, I created it, and I was thinking like, cool, I have 1 million Signa here, and I'm sending 1 million Signa to that account because that will be my HODL account. That will be my cold wallet account, or whatever you want to call this. And I just sent it by the ID, and then there is no attribution of the public key. That means that the system, the blockchain, does not exactly know who is really the owner unless somebody comes with a full public key. That means it opens space for all these access here. I want to say like, I need to find a public key, or better to say that I need to find a key set including private key and a public key that matches only the first
Sorry,
8
Oliver,
byte.
we lost your sound.
I'm here. My
Yeah, we
sound is
don't hear
away.
you.
I have done
Or maybe
nothing.
I lost my sound.
I don't know. Can you hear me? Is there something like that? Sure. I'm asking Alistair. So many trouble with technical difficulties. One, two, three. Let me see if he's answering.
Sorry, guys,
It's
I lost
there.
my sound. Sorry, it's my problem.
Okay, so I can continue. This was your side. Okay, gotcha. I'm good. Yes. Okay. Cool. So, Alistair, thank you for backing my ass. Okay. Just to say that. So I just need to find a set of keys where only the first 8 byte matches. So I have effectively a protection by 64-bit going on. So what does it mean? Imagine I can generate n public keys per second. So that means a key set per second. How long does it take to find a collision for a given account ID? So how long does it would take me under naive circumstances, like saying I'm making a brute force attack or brute force guessing? And if I, for example, if I can guess 1 million key sets or public keys in a second, then it would take me about 500 and 557,000 years to find a collision on a 64-bit namespace. This is a lot. So 1 million guesses. If I go a dimension higher and guarantee, okay, let's make 1 billion, then it still takes me 444 years to find theoretically a collision. This is statistically spoken. There are algorithms outside there can have the security. They cannot like they can be more. They can double the speed or something like that. There are possibilities with the smarter guessings and all the stuff to attack this a little bit more efficiently. But in the end, it does not mean that it's really changing the dimensions or the efforts at all. So if you see that I get going over to 1 trillion, so one more, then it's already possible in a little bit more than a half year. And if I'm very close to my 64 bits, so if I have 2 to the power of 50 gases per second, so it's called 1 quadrillion. I even needed to look up the number in Wikipedia because I didn't know that. And it takes me about 16,000 seconds. So it's within 1 day I can attack this account number. So this 1 quadrillion, regarding to that what was ongoing, Delitarium estimated that someone had about 2,000 GPUs, modern GPUs, somehow got together to make this kind of cracking possible. So it's widely known that 64-bit cryptography is unsecure since years already, just to have this idea. Okay, so not only in Signum, but all over the world, 64-bit protection is not sufficient anymore. And just to remember that if I would go up to 65-bit protection, then I already doubled my security. So if I go to 66, then I doubled my security and also on. So where we are now, the stance is like military grade protection is by 128 bit further. So this is what is coming from our public key stuff and all the stuff. So if you're cracking account IDs, is only I said that cracking account IDs is only possible if no public key is assigned to an account, and this is very vital. I showed you that the public key is being automatically assigned. So if you see that when going back to that account that we just created, so that account, let me see if I can see the details, account details here. It shows me already that I have a public key here, that is the ID, and I got a protection from the activation service. So this is implicitly, automatically built into all our wallets, just like to say that. So saying that, let me see, cracking account IDs. So with a public key assigned to the accounts, with a public key assigned, the accounts are secure, you can see. So cracking a public key is not feasible. And now I want to show you a little bit like under this same assumptions. Hopefully I'm not totally wrong about that. That if we start with the same power that we ended on the 64-bit, we stopped here at quadrillion. You see there was like in a few seconds or 60,000 seconds, we were able to crack that. So if we go on starting with that, like here, 1 quadrillion, it takes us two to the power of 78 seconds, which is about 3.5 times 10 to the power of 18 days, which is, well, I looked up how long the physicists, the astrophysicists are estimating the existence of the universe. And if this is the big rip scenario, which is not really, people don't know if this really happened, but there are kind of theories about that. It says like in about 22 billion years, the universe will stop to exist. This is the least number of existence for the universe. And we are six exponents on top of that, because billion is elevated to power to 9, and here's power to 15. So this is with this power here. So if we go up further and further and further and further, you see that it's still like billion years, still like 10 billion years here. And if we come in close to something like at this year, I don't have even a number for that. So it takes about 3 days. And when we are in a scenario here, so there's something that I looked up also when we call looking into Moore's law. Moore's law says that every 18 months, the density of transistors is doubled. And more or less implicit saying like, if this is doubled, then the computational power is doubled also. Well, there are kind of nowadays like some differences of saying like, if the Moore's law is still active or not. Well, this would mean that every 18 months, our current security lowers by 1 exponent. And this has practically no effect. So it still would like saying roughly, let's just like, instead of 10 to the power of 15 years, it will take us 10 to the power of 14 years. Makes no difference at all. So, of course, there will be the quantum computer stuff. I cannot say anything about that. We are prone to that. Every blockchain, I think, is prone to that. That must be considered. This is another discussion, and I'm not an expert on that. I don't know really what does it mean, post-quantum cryptography and all this stuff. But, well, from the current state of the stuff, yeah, Schiffers, you're coming up here.
Yeah, I have few sentences. I just looked at before the stream about this quantum computing, and there is two algorithms. And in theoretical, if we had quantum computer, you can take square root from if we have 256-bit security and we have quantum computer created, it is can be considered as 126 bits. So
it's half. In our case, actually, it's like we have a security of 128 bits, even if the key is 256. But yeah, so it goes down to 64. Then it's crackable.
yes.
How many qubits we need for that?
It's a theoretical algorithm. I don't know how many. It's a very fishy station about this quantum computer, and it is not fast, and it is only in theory.
Yeah. This is
And
something. Yeah. I mean,
it
the
is
entire
not.
internet is prone to attack of quantum post-quantum stuff. Yeah, I know
Yes.
that. So our problem will be another than just like Signum or Bitcoin or whatever.
Is in my view, quantum computing is just creating big highlights, big I don't know names. I mean, big titles that it will crack and etc. And I see it in maybe 10 years and still nothing, only theory, and
Yeah,
we will see. We will see.
we will see. Yeah, but we adapt to that. So as a final outcome is like rules to secure account in Signum is like use a random seed, no on text always, and get your public key assigned. Of course, that sounds. I showed you already. I said rules for a secure account means in a more user friendly way. Create your account with one of the official wallets out there: Phoenix, BTDEX, XT Wallet, Neoclassic, and the upcoming mobile wallet. I can say that I start on by March. I will start working revamping the existing not fully functional mobile wallet. So thanks to Time Walker again on this channel here, that he helped me on that, and we will bring this to iOS and all the stuff. But they're all the same mechanisms behind that. We're using the activation service behind, and so it must be, in terms of user friendliness, it must be as easy as possible to do so. I know this is not easy for people who just start on crypto coming. It's very confusing, I know that. And so that's up to us developers to make it as secure on one side, but also as user-friendly as possible. And yeah, as I said, accounts created with the official wallets are secure. So you can really, from that standpoint, so it means like we're creating the accounts, we're using most possible randomized seeds, and we also make the activation, the assignment of the public key. I think that's pretty much all what I have to tell about this. I'm not sure if there are questions. This is up to you, Sheffield, that you moderate that for me, and I try to answer where I can.
I have some questions. So our public key is 126 bits.
The security behind that, yes. No, wait. Yeah, it's just like that. Okay, I have to explain this a little bit because it's confusing. The elliptic curve creates a 256-bit key, which guarantees a 128 bits of security. I read it up before that because I was confused by that also. That's, for example,
Okay.
that's why elliptic curves is more interesting than, for example, RSA. So the same security, to get this with RSA, you need much larger keys. It's just the key has 256 bit, but the security we have is 128 bit. If you look at the EC curve, and this also counts for BTC, Ethereum, all the stuff, because the SEC 256 algorithm means that there are 256 bit keys that are generated and giving that kind of security. That's why I did that. But it sounds like, hey, 64 to 128, this is just double the stuff and double the security. But it's really important to point out that the exponent, just like raising it by one, doubles the security. So we not only doubled that, we just like, I don't know that, we just like increased this exponentially. So a 128-bit security is given nowadays, and this is considered secure.
Okay, so we don't have related questions to your presentation. Probably
Okay. That
I will
means that it
give.
was a good one.
I don't know.
I'm not sure if the people are more confused.
So we have 6 persons who entered this giveaway. So
Okay.
it is last few minutes to enter your Signum address and win this NFT.
Yeah.
I will.
There
I will.
was. Yeah, go.
Okay. I
No,
I will
no.
give some more shout outs. Next Sunday we will have another stream, and we will have Frank, who will maybe, and Oliver, I don't know, and maybe some others guys who will talk about our future, and it is related to questions which we can answer. It is this one. How is the vote going with nodes for the fork that you had to initiate? Next stream will be 26th February, and
Yeah.
our vote is until 22. So we will have vote results.
Yeah.
Maybe you want. Okay.
If I'm not totally wrong, it is like that the majority opted for the 3.6 version at this moment. And after that vote, that's very important. That after that vote, we need to decide together what we want to do with these frozen accounts. This is very important. I cannot take any position about that because this is totally up to the community. The problem is that affected accounts on that are all these non-public key accounts from before 2019, by the way. And we it's not easy to reach the users and to guide them somehow because people are not responding or they forgot that or not inside anymore. That's the downside of this anonymous thing. So it's good that it's just like that, and but it's tricky to get these people on board. If there's somebody out there and is like in doubt right now if his account is protected, just go to the Explorer and see if there's inside the Explorer the public key assigned to it, or log it into the. Let me see. I can go, for example, taking my account here. For example, I'm kind of going here to the Explorer, and if I'm opening that, then you can see if that one is here, that public key, then you know you're safe. Okay. But we figured out that since we introduced the activation account, there is really a very small numbers of accounts. Don't know how they were created, which have probably with a classic wallet, they don't have a public key assigned to them. So the most part of that is before 2019, and this was before when I entered and when the BAT and that old times entered and all this stuff. So yeah. That's it. So, but I can only tell all the people, go out and check if your accounts have this public key. If not, if you have doubts how to do this, just ping us on Discord, on Telegram, whatever. We are here to help on that part for sure. And yeah, that's just what I can say. It's a kind of different, like works on BTC, for example. I don't know exactly why the creators of the blockchain, this was not me and was not the current dev team, why they made this design decision. It's like a feature, it's not a bug. It's just, but we mitigated the risk as fast as possible, as good as possible, using, for example, the activation server. Yeah.
Okay, guys, so you can ask a question if you have very good opportunity to get answer from Signum developer. If you have some questions, probably I will say some other stuff, but every creator of Signum related ecosystem can join this stream. I mean, I will try to, if I have guests and people who wants to present products, his art, or I don't know, his ideas, I can organize such streams and present to community. So welcome. We are open and
Yep.
we can discuss all questions.
Exactly. Don't hesitate to ask. So, if there are no more questions right now. That was fast today.
Yes.
Okay, it's good
Okay.
fun. Yeah.
Okay. I don't see any new entries of Alexander. So you have few seconds to write your Signum address, and I will do this drawing.
Yeah.
Okay. I will do it. And winner is some ads.
It's more
Easy
ads than anything
PD.
else.
I don't know who it is.
Yeah. Congrats. That
Congrats.
magic mushroom is crazy. I was about to buy it, but Chifis did before, and I don't want to pay more for that.
Sorry, Alexander, you little bit late. Okay,
He lost it.
yeah. Few seconds.
Oh
Okay,
man.
guys, Alexander, you can. We will do some giveaways for the next Sunday stream. And I like I said, if you are NFT artist or someone, you can direct message me, and I will promote your stuff. Okay, bye.
Bye.